My name is Mark Orr and I'm the Executive Director of the UK and Ireland Spill Association, and welcome to this webinar from our Plastic Pollution Working Group. And in particular, this is part of a webinar series that we're doing around 10 different webinars which represent the goals that the group is working to. And this is on identification of effective tools and equipment for controlling plastics at source. So UK and Ireland's Spill Association is the trade body for marine and inland response companies in the UK, and it represents contractors, manufacturers and consultants who work in our industry. We also have an accreditation activities in inland oil and chemical spills and delivery of the Maritime and Coast Guard Agency scheme for the accreditation of marine spill response organisations, which is run through an independent accreditation body called the International Spill Accreditation Scheme. Now, to support local authorities who in the UK have responsibility. Dan, can I just ask you to mute, please? To support local authorities who in the UK have responsibility for the shoreline within their area of management, the Environment Agency asked our association to develop a nationwide response plan so that when plastic arrives on their beaches, removal could be safely and promptly arranged. Now, this followed a number of incidents that occurred in late 2000 and late 2019 and early 2000. And basically what was happening was plastic was arriving. There wasn't a plan to sort it out. The Environment Agency got involved because the councils went to them and said, what are you going to do about it? There wasn't really a clear plan. The quantities were not significant enough to trigger the initiation of a national response plan. So effectively, bit by bit, the plastic disappeared. So it became obvious that this wasn't the way that things should work and that we needed a coordinated response plan, which is where we got involved. So the group formed and we ended up developing this plan, and this plan is still in place. But it soon became obvious to the members of the group that this was useful, it solved a problem, but the mission became much larger. So we grew into a multidisciplinary group of member companies, regulators, academia, and of course, I'm sure the group will continue to grow. Now, when the MV Express Pearl incident occurred off Sri Lanka in May 2021, it involved the deployment of a number of our group's members. And as this is the most recent incident where there was a significant spill of nurdles, with awful consequences for the marine life, shoreline, local environment, and the local fisheries, there is much to learn from it. And there's been other recent incidents since, which involved our members, the MSC Zoe, which lost 345 containers in the southern North Sea, which spread its contents of several of the containers which contain plastics across the Wadden Islands. Some of the containers sunk, but they're still releasing pellets from them, which have impacted Danish and German shores. And we've had other smaller incidents which members have dealt with. And if you're an avid follower of LinkedIn, you'll see that off the west coast of France recently, there's been ending up on the shore release of nurdles, which has affected their coastline, and CEDRA have been involved in that. So with the live learning which goes on and the experience that we've been building from the MV Express Pearl, the group decided that we should share what we learn by collaborative production of a series of best practice guidance documents and webinars. And earlier last year, the group committed to a series of goals which will be completed by the end of this quarter. And we also agreed that our work would cover microplastics only at this stage. Now, the European Maritime Strategic Framework Directive guidelines define microplastics as plastics with a diameter of less than 5 millimeters. And it is used as a standard measure in the analysis of marine and freshwater ecosystems. So the goals that the group set itself were pretty ambitious, and but we are delivering them. And I've listed these goals here. And so each of these goals is going to be delivered with a peer-reviewed report and an accompanying webinar, such as the one you're seeing today. Those are some of the goals. There's another 3. And you can see the members of the group, the plastic pollution working group, who are on there. Now, today's webinar is the delivery of goal 10, the identification of effective tools and equipment for controlling plastics at source, i.e. on the manufacturing site or storage site or logistics site, in drains and in rivers. In other words, what can we do to try and prevent it getting to the sea? Now, this is going to be presented by 2 very knowledgeable, very bright, affable, friendly young men who are much younger than me, but very bright environmental consultants, Josh Duran and Kif Kalern, who both worked on some of the reports which Oracle Environmental have been doing. They're from Oracle Environmental Experts. And so I'm going to stop sharing and hand over to them. We'll take questions at the end. And please drop in any comments that you've got that you want me to raise into chat so I can host questions at the end. So, gents, over to you.
Nice one. Thanks, Mark. Let me just get it up. Right, is that all showing up?
That looks great.
Fantastic. Great. Yeah, thanks everyone for attending today. As Mark kindly mentioned, yeah, I'm just an environmental consultant with Oracle Environmental Experts. I've got a background with a master's in marine biology, but I'm also an avid surfer, scuba diver, and beach cleaner. So this is right up my street. So this is the second webinar that Oracle are hosting out of the 3 that we've got, and the 3rd in the series so far. And OEE been part of the plastic work group sort of when it started back in March in 2021, sort of looking at sort of several of those goals, which I'll come to into in a minute. And yeah, so basically, yeah, what we'll be looking at today is identifying those effective tools and equipment for controlling plastic at the source. So there's sort of, and again, another little summary for you here of what we outlined for our 10 sort of quite ambitious goals as part of the working group. So the first one we've done so far, which was from ourselves understanding the problem from the source to sea. So that again is out there with the webinar and then the paper on the UK Spill website. And then also goal 5, which Mark did last month. So yeah, today we'll be looking at that goal 10, and by no means does it mean it's 10th on the list. If anything, it's probably one of the most important ones, trying to stop it. I mean, also eradicates everything else above it. But yeah, so what we have here is just basically just a very quick rundown of what we'll be talking about today. Looking at the problem of plastic pollution and again, mainly microplastics, then breaking it down into those different ways that can be controlled from source, as Mark mentioned, from either the manufacturing side, but even once it gets into rivers and the different ways and the sort of equipment that's already out there, and then sort of wrapping it up with any conclusions. As Mark mentioned, if you've got any questions, please just put them in the chat throughout. I'll sort of keep an eye on it from those side of things. But without further ado, I'll put you across to Kit.
Thank you very much, Josh. Good afternoon, everyone. Thank you for joining us for this webinar. I just wanted to point out before we start that we don't have any affiliation with any of the companies that are mentioned in the webinar. And it's really not an exhaustive list of everything that's out there. As you're about to see, there's a huge amount of tools and technology that's out there at the moment, lots of them under development, and it's quite exciting, but it does move at quite a fast pace. So we won't be covering absolutely everything in this webinar. So I thought we'd start by looking at the scale of the plastic problem that we're facing. So in 2020, 367 million tons of plastic were produced worldwide, and that's expected to double in the next 20 years, so a colossal amount. The majority of that plastic is going to end up in landfills or open waste sites, like you can see on the screen there, or through littering in our environment. And a huge proportion of that will end up in the rivers and lakes and eventually, of course, our oceans. Currently, it's estimated that between 19 to 23 million tons of plastic enter the aquatic ecosystems annually from land-based sources. So obviously limiting the amount of plastics by preventing them from being released from the source, by using those effective tools and equipment and technologies is going to be key to reducing the amount of plastic that actually ends up in our oceans and, of course, the wider environment. So the aim of this webinar is to outline some of those current tools that are being used and equipment that's in developing, all for controlling the plastics at their source. And as I said before, it's by no means an exhaustive list, and we'll look to update this as more kind of research and technologies are produced. So Josh briefly showed the contents page where we've kind of broken down the webinar into the various sources of plastic. And then we've broken it down further into the technology and research that's happened around preventing the plastics from being released from those sources. We're going to start with looking at rivers. Rivers have been consistently identified as one of the most important transport pathways for all sizes of plastic debris, from your larger macroplastics, so much larger plastics, down to micro and nanoplastics. Rivers are obviously highly dynamic environments. They connect land to sea, and along their course, plastic can enter the rivers through road runoff, agricultural runoff, or through wastewater inputs like those from wastewater treatment plants, and of course through littering. And I've put a stat on the slide there. It says globally it's estimated that between 1.15 and 2.41 million tons of plastic waste enters the ocean every year from rivers, and that's rivers alone, so huge amount. So in order to stem the flow of those plastics from ending up in the oceans from our rivers, there have been a number of boats and barges that have been developed to collect and then recycle this plastic waste within our river systems. The ones that we've identified tend to use processes such as collecting the surface plastic and then transporting them via conveyor belts, baskets and sieves, where they're collected and then taken to the shore so they can be recycled once they've actually reached the shore. So the first one of these barges is called the Interceptor, rather dramatically named. But the Interceptor is an autonomous system that's used for collecting plastic pollution before it reaches the sea. It's developed by the Ocean Cleanup, which you will hear a lot of in this webinar. They seem to be producing all kinds of tools and technologies helping in cleaning up plastics from our waterways. So this barge is essentially anchored to the riverbed. And you can see in the image on screen there, we have it consists of a floating barrier which funnels the plastic waste into the mouth of the barge. The barge itself is powered by solar panels, which you can see at the top of the barge there. And then once on the conveyor belts, the plastic is then dumped into a barge that's waiting below the plant, where then a computer system will tell it once it's full, and then a team will come out and take the barge onshore to be recycled. The Ocean Cleanup state that one of the benefits of this system is that it only spans part of the river. So that obviously has benefits in that it allows river transport to pass through, and of course wildlife as well. Moving on a little bit, also by the Ocean Cleanup, this little boat is called the Interceptor Tender, and it's designed to work alongside barrier deployments like the one you can see in the image there. It's a small powered barge. It's got these arms that reach in and kind of scoop up the waste onto a conveyor belt that's on the boat, and then it's then collected in a container on the back and then taken to shore to be recycled. They state that it's capable of servicing multiple barrier deployments in close proximity. So you could have a series of these barriers all quite close together, and the Interceptor Tender could come along, scoop up the litter, take it to shore where it can be recycled. Now, one of my favorites, if for nothing else other than it has googly eyes at the front, this is Mr. Trash Wheel. And again, it's kind of similar in design to our first one that we looked at, the Interceptor, in that it uses containment booms to collect litter, including plastics, from flowing along a river where it can be collected. Slightly different in that it obviously spans the whole width of the canal. It looks like that it's in this case. But it is powered by solar panels in much the same way as the Interceptor was, and also by a 14-foot water wheel that uses the river current to power it along. Unlike the other systems as well, this does actually require human operation. It requires somebody to actually rake the plastic waste onto the conveyor belt, where then it's taken, collected, and then again taken away onshore to be recycled. DESME have also designed and installed various floating litter containment and collection systems for collecting plastics in rivers. We've got the automated trash removal system on the left, and then the smaller treat unit on the right. The smaller one that you can see on the right there is essentially designed for watercourses that contain less litter. So it's marketed as being lightweight and low cost. And it's, like I say, designed for lower capacity demand areas, and often those areas that have difficult access, hard to get to. This can be deployed by using a boat as well. It can all be wrapped up, taken on a boat. And then you can see in the image there, it works by a series of guide booms directing or funneling the plastic into a bag, and that bag then can be emptied and replaced as necessary. Here we have something slightly different. We've got the 4Ocean mobile skimmer on the left, and we've got Versicat trash skimmer boat on the right. Now, these two, rather than remaining stationary in the water and using containment booms rather, to funnel the plastic like we've seen in our previous examples, these two use onboard motors, and the 4Ocean mobile skimmer uses retractable arms to essentially scoop up the plastic in open waters, where then it gets moved onto a conveyor belt and then again taken back to shore where it can be recycled. The trash skimmer boat on the right works in a similar way in that it's powered by an onboard motor. It can scoop up the litter, but in this case, it has a series of pods or baskets where the plastic is then contained. The idea being that when it's taken to shore, it can be unloaded onto the quayside without the need for any strenuous manual handling. So moving away from boats and barges, there have been efforts made to automate the process of plastic recovery from rivers. Drones and robots obviously have the benefit of being able to operate independently, and in some cases they can clean faster and more efficiently than human operated systems. So let's have a look at two examples of those. We've got the Waste Shark on the left, and we've got Fred on the right there. The Waste Shark is an autonomous water drone created by a company called Ram Marine Technology. And really, it's developed to collect floating waste, including plastics, before the winds, tides and currents carry it out into the ocean. So really designed for smoother, calmer inland waters, maybe in harbors, marinas, that kind of location. The Ram Marine company claim that it's been designed to be user-friendly and easily deployable. It's quite lightweight and low cost. And a drone like this is suitable for use in those harder to reach places, perhaps more dangerous places where you wouldn't really want to put a human operator. FRED on the right, well, FRED is an acronym. It stands for Floating Robot for Eliminating Debris. And this one is a solar-powered, semi-autonomous robotic catamaran. And it's capable of collecting mainly macroplastic pollution rather than microplastics, so the larger scale plastics that are floating on the surface of the ocean. Originally developed for use actually in the oceans, The company claim that this can be scaled for use depending on the operation that's happening. So if it's out in the ocean and it's quite a large amount of litter, you could kind of scale it up, or if it's something inland, then it could be scaled down, whatever purpose you require. This one is called the Jellyfish Bot, and again, it's an autonomous but multi-purpose bot, and it can be used for the collection of waste and hydrocarbons, including microplastics. This remote control bot essentially works by dragging interchangeable nets behind it. You can change the nets out for different sizes depending on what contaminant you want to collect, and then obviously you can clear the net and then replace it to collect more litter. So we've looked at drones and robots, and we briefly looked at barriers when we looked at our first slide with the interceptor system, but actually they deserved a whole section of their own because there's a huge range of barriers, as you're about to see. And barriers simply work by catching plastics and other debris as it floats down the river system towards the sea, just by using the natural flow of those rivers and accumulating the plastics. We've seen already that barriers can either be installed across the whole span of the river or just part of it. And if they're installed across part of it, it obviously allows wildlife and river transport to pass through unhindered. So 2 examples of the more kind of traditional barrier that we've looked at already. We've got the interceptor barrier on the left. Again, this is designed by the team at Ocean Cleanup, and it's a variation on the barrier that's actually used in conjunction with the interceptor itself, like we saw in the first slide. The main difference being is that most of the barrier is permeable. So the idea is that that can be optimized then for buffering the plastic waste in the water. And it basically consists of a floating barrier, often anchored in a U shape around the mouth of a small river or an outlet where plastic needs to be collected, and then that intercepts the plastics and it's buffered until it can be removed from the water to be recycled. The one on the left is Claims Marine Litter Containment Floating Boom. It's in its pilot phase, so not currently in development for use yet. But this one has been installed in the mouth of the Kifissos River in Athens, in Greece. And it's a solar-powered system that essentially works by the booms directing the plastic towards the containment system that you can see in the foreground there. And then the containment system is made up of a series of sieves that can kind of filter the waste, and then the sieves can then be pulled onshore for recycling. Again, it's something that's in the pilot phase, and it'll be interesting to see kind of the development of this and to see if it actually gets into full-scale production. Something a little bit more innovative, looks a little different to the barriers that we've seen so far, is the Great Bubble Barrier. This one is developed by a Dutch startup company and essentially uses the idea that bubbles can trap and remove the plastics from waterways like rivers. So a bubble curtain is created by pumping air through perforated tubes, and the tubes are installed on the bed of the river. This bubble curtain then directs the plastics towards the surface, and by placing the bubble barrier diagonally across the surface of the river, this allows the natural flow of water to push the plastic waste to the side. And you can see in our images there on the left, you've got kind of a mock-up diagram, and the idea being that the bubbles will push the plastics to the side, the containment system that you can see in white there, where then it can be collected and taken away for recycling. Now, the startup company claimed there are lots of benefits to a system such as this one. One is that it obviously doesn't disrupt transport in any way. Boats can pass along freely over the top of the bubble barrier. It also doesn't disrupt any wildlife. Additionally, they claim it can be run up to 24 hours a day, whereas if you had, I suppose, a physical barrier in place, that might have to be removed at certain times of the day if you've got lots of traffic moving past. In addition, they claim as well that the bubble curtains are thought to increase the dissolved oxygen in the water, which obviously benefits the aquatic ecosystem. Now here, Josh has kindly put in a little video that goes along with this. This is the river cleaning system, and you can kind of see how it works by the river, by the video going on in the background. But essentially here, you've got a series of floating discs that are installed diagonally across the river. The discs move just with the current of the river, and they basically will catch and direct any plastic moving past on the surface towards the containment bin that you can see in the image on the right there. The idea is, and you can see in the video there, that the boats and wildlife can move past fairly easily, and they can just push past, and the disc will just move back into place. And finally, for our barriers that we came up within our reports, this is another system. It's called the trash fence, and again, it's designed by that team at the Ocean Cleanup. Really, this one is designed for really highly polluted flash flood environments. And again, you've got an image on the left there, and you can see the scale of the fence itself. If you can see in the bottom left, there's an image of a guy wearing a red shirt. So this is a colossal project, if you like. And on the right, you've got a video just playing in the background of this working. Currently, this is in its pilot phase. The system itself is based on an avalanche system, whereby the fence itself is anchored to the bed of the river, but also the banks of the river as well. And I think as the image, the video shows, because it's in its pilot phase, this is actually downstream from a quite polluted city, and this is in one of the most polluted rivers in the world. And during the flash flood event, pushes huge amounts of water and plastic against the fence. And in this case, it actually ended up undermining the structure. You can see it in the video there, just because of the huge amounts of water and plastic flowing past. It'd be really interesting to keep an eye on this and to see if they perfect the system, and yeah, keep an eye on it for the future. We've got a little section here for other solutions that didn't really fit neatly into any of our other sections, if you like. In this one, we've got the sea bin on the left and the port bin on the right. So the sea bin is created by the Sea Bin project, and it's essentially a trash skimmer designed to be installed in calmer waters like those in marinas, yacht clubs and ports. And basically it behaves like a floating litter bin. It skims the surface of the water by pumping water inside the bin, and then the plastics are then collected in a bag inside. The bag can be changed out for different sizes, different mesh sizes, so you can collect plastics, and they claim microplastics down to 2 millimeters in diameter, and then clean water is obviously pumped back into the marina. On the right, you've got the port bin there, which is produced by Spilltech, and it is essentially the same idea and designed to move up and down with the tides. So this one is quite an interesting one. This is the Archimedean drum screw. Drum screw cleanup technologies have been developed, have been around for decades. This one is very much in its pilot phase, and it was initially designed for jellyfish removal. So a company called Fishflow, in partnership with Inner Plastic, have developed and built a full-scale model of this Archimedean drum screw. The idea being that it will pull water up and deposit any plastic-filled water onto sieves, where obviously then the plastics can be extracted, taken away for recycling, and they claim that 90% of the water flow is then able to pass through. So the technologies that we looked at so far have really require microplastics to be above a certain threshold size, so that then they can be removed by sieves, nets, and meshes, and that kind of thing. So this is a project by Inner Plastic again, and it aims to investigate flocculation on micro and nanoplastics in order to form larger clumps or aggregates, if you like, which can then be more easily removed by sieving. In addition to this, a new innovation in cleanup technologies that we discovered is the agglomeration of nano and microplastics in waters with the help of ultrasound clustering. So this works by generating overlapping ultrasonic waves, and then the microplastics and other particles are pushed along the lines of those waves to the nodes, where they consolidate basically into clusters, which then can be treated to the flocculation process to develop larger clusters. This is, again, very much pilot phase, and I know that Innoplastic, the company behind this, are looking at effective ways of scaling this up on a more industrial scale. So another one interesting to keep an eye on. So moving on from rivers and waterways, we're going to have a look at another source of plastics, and that is via stormwater and drainage systems. So most marine-based plastics originate from land-based sources through processes such as surface runoff, wind, littering, and other sources. And that plastic often finds its way into marine ecosystems through stormwater drains. And the stormwater drains obviously allow the runoff, which contains that plastic and other debris, and allows it to travel into larger bodies of water, which then subsequently will carry them into the ocean. Stormwater and road runoff in particular have been identified as significant pathways for plastic pollution. And I know our Goal 1 report goes into some detail about road runoff. So it's well worth looking for that. So what are some of the solutions to this? Well, you can install litter traps like the one in the image here. This is the Enviropod litter trap, and it's essentially a catch basin basket that sits inside the stormwater drain and prevents litter and plastics carried by the stormwater from entering the drainage system. The litter trap in the picture can be combined with liners or meshes that can target site-specific pollutants down to pellets or nurdles. They claim down to 1 millimeter in size. Now, obviously, once that filter bag is full, it needs to be removed, and that can be removed manually, or it can be removed by a vacuum inductor truck. And if the filter bag becomes full during high flows, if it's too full of water, then it's designed so that apertures will open in the top of the frame to release that water. One potential, I guess, downside of a system like this is that it does require quite a lot of maintenance, particularly if it's a highly polluted environment with lots of plastics. It's going to require the meshes to be changed out at fairly regular intervals, which obviously has cost and practical implications to that. Here we have Penstock and Toggleblock valve from Penstock Solutions. And these are automated bungs and drain stops, and they can be installed in drainage systems, often in industrial sites where there's a high risk of a pollution incident happening. So following a spill, these can be automatically closed to prevent any pollutants, including plastics, from being washed out into drainage systems and subsequently, finally, the ocean. And these are being used currently on microplastic pre-production pellet factories or nurdles, and where there's been loss of pellets. And at the other end of the system, other end of the drainage system, you can have end of pipe screening systems like the one shown in the image here. I think this one is in a system in the USA. And these are really installed as a system of a last defense, really, more designed to catch larger debris, including plastics, as it moves into larger water bodies. So we're going to move on and look at some wastewater solutions. Wastewater in developed nations is generally treated at wastewater treatment plants, which are actually thought to be very effective initially at removing plastics, including microplastics. However, much of the microplastics are incorporated into sewage sludge, which is often used as fertilizer for agriculture, which suggests that actually agricultural soils are large sinks for microplastics, which then they can be reintroduced into the marine environments via processes like surface runoff. And a stat here that microplastic fibers have been reported in agricultural fields up to 15 years after that sewage sludge was applied. and still retaining their original properties. So quite a significant source of plastic pollution. And again, there's lots more information about wastewater treatment plants and microplastics in our Goal 1 report, which you can find, I believe, on the UK Spill website. So microplastics themselves can actually enter the wastewater treatment plants from quite a wide range of sources. Though a really important source appears to be through sewage contaminated by fibers from washing clothes. It's thought that microfibers are generated in wash cycles through the abrasion of synthetic textiles during a laundry cycle, as well as exposure to chemicals and detergents. And this obviously leads to the breakdown of those synthetic fibers into much smaller microfibers. And it's been found that more than 1,900 fibers per garment can be released per wash. And that works out as the equivalent of 100 to 300 fibers per litre of effluent. So quite a source of plastic pollution. So as we've seen, when synthetic clothing is washed, tens of thousands of microfibers are released within the wastewater in each load. So what's being done about that? Well, some washing machines now are being fitted with inbuilt microplastic filters. One example that we came across was the Grundig fiber catcher. But for a washing machine that has an inbuilt micro filter like that, you can probably expect to pay a premium for that service. But you can buy add-on kits. So like the one on the left here, this is a product by Planet Care, which are available to install onto standard washing machines. And they claim to prevent up to 90% of microfibers from being released with each laundry load. The kit does require the cartridges that you can see in the image there to be replaced on a fairly regular basis. Planet Care state that that's every 20 washes. And you know, 20 washes is not a huge amount of washes, particularly if you live in a busy household with a family, perhaps. The cartridges are then sent back to the company where they are emptied of their microplastic fibers. They're recycled, and the cartridge then gets sent back to you. Another solution to prevent the release of those microplastics in the laundry cycle are things like laundry balls. And you can see one on the right here. This is by Corable. And it's basically placed inside the washing machine during that laundry cycle and is designed to pick up the microfibers in the stalks of the product. And some research in 2020 by Napa at the University of Plymouth was able to demonstrate that the Corable prevents 31% of microfibers from flowing down the drain, in addition to reducing the amount of shedding taking place in a typical wash cycle. So not only does it help prevent the microfibers being released into the effluent, it also prevents the shedding in the first place. So the final source that we are going to look at are pre-production plastic pellets, or as they're otherwise known, more commonly known as nurdles. So nurdle loss is the second largest source of direct microplastic pollution in the ocean, and it's known to cause serious harm to marine biodiversity. As an estimated 230,000 tons of pellets are lost to the environment every year, a huge amount. And pellet loss can occur at every stage of the supply chain, whether that's a loss at pre-production facilities or factories, whether that's a loss through when it's transported or when it's stored, or eventually when they're converted into their plastic products. Technology has rarely addressed the loss of industrial pre-production pellets during transport or through use or improper waste management. Instead, what we found is that pellet loss can be prevented by implementing robust procedures, providing spill kits, training on staff how to use them, and of course through putting filters in drains in high-risk environments like the ones that we've seen previously. So currently, plastic production companies can opt in to sign up to Operation Clean Sweep, or the Operation Clean Sweep scheme, I should say, or the OCS for short. And that essentially commits companies to zero pellet loss from their facilities. The OCS document provides a comprehensive set of guidelines to help companies make sure that no pellets are lost from their sites. There are a number of resources available in the document and from their website, and these include things like checklists for site audits, checklists for equipment and training. However, signing up to the OCS is currently voluntary. There are no checks on companies to make sure that they're following through with their pledge of zero pellet loss. And this is something that was introduced nearly 30 years ago, and there are still pellets being lost in their billions. Now, companies involved in the production, transfer or use of plastic pellets are encouraged through the OCS scheme to provide spill kits that are easily accessible to any employee in the company. In case of a spill, these are fairly simple in their design. You can see one on the left there. They're just simply made up of a bin, and you've got a dustpan and brush and spades, but something where you can easily clean up the spill, along with some kind of visual awareness. You can see in the picture there, making employees aware, I suppose, of what can happen when pellets are lost, and making them aware that actually it needs to be managed and spills need to be cleaned up. Vacuums can also be used to clean up spills. On the left here, you've got the LG PowerVac, a slightly higher power that can be used in factories where there's potentially lots of pellets lost to the environment. And we are seeing as well that lots of handheld vacuums are being given to employees where pellets are likely to be lost. So tanker drivers, workers in the factories, so that then it's easily accessible and they can use it to clean up any pellet spills. There are catch trays that you can see on the left there that can be used, and these are simply just placed underneath areas where spills commonly occur, such as beneath tankers or beneath silo ports where they're loaded and unloaded, and within transfer hosing as well within factories, and that helps prevent any pellets from being lost to the ground. Stormwater drains at plastic production facilities are also a potential pathway for those pellets to enter the stormwater system and then obviously the wider environment. So these high-risk drains can be covered with rubber sheeting that you can see on the right there. So that prevents any pellets from being lost down the drain, but then allows the water to pass through. And of course, there are more advanced solutions, such as the installation of stormwater litter traps like we've looked at before, or the penstock valves in our previous slides. And this, I think, combined with a routine cleaning schedule, proved to be effective barriers against pellet loss to the wider environment. And finally, we have simple but effective approaches like visual awareness schemes, like the ones you can see in the image here. On the left there, we've got simply some painted curbstones next to a drain. All drains lead to the sea and only rain down the drain. And it's just really to highlight what happens to litter when it's dropped, what happens to plastic when it's dropped, and allowing pedestrians and passers-by to take a little bit more consideration, I suppose, when they're passing. And this, combined with other schemes employed by local councils, like the posters you can see on the left there, no more rubbish excuses, or my favourite, don't be a tosser, on the right there, they grab the passers-by attention, and it's an effort really to persuade them to dispose of their waste instead of littering, really. And essentially, I think that's what it needs to be. We can have all these solutions in place for preventing the plastics at source, but really we need to kind of end our reliance on them and educate people to manage plastic properly. So really, that's about it from me. And as we've seen, plastic pollution is a complex and extensive problem, and there's no real one simple solution to it to address it. However, hopefully, as this review is hoped to show, there's a huge amount of projects and initiatives out there that are continuing to develop all the time to help reduce the plastic waste from their sources, and therefore limit the amount of plastic waste entering our environment. But fundamentally, as I said before, and it's not really addressed in this review, but there just really needs to be a vast reduction in our reliance as humanity on plastics, and moving away to something else. Josh has kindly put there on the end slide here some food for thought, I suppose, thinking about going plastic free, doing what we can. And there are a couple of websites there that kind of help think about reducing our reliance on plastic and things that we can do as individuals to prevent plastics from being released to the environment. I think that is it from me, and time for questions, I believe.
No, I've got to carry on with a few bits. If you can unshare and I'll share.
Yeah, sure. Okay, I'll let you do that, Josh. You can.
Thank you very much indeed, Kif. That was grand. I'm just going to show you some other guidance which might be useful. Let me just. Okay. Hopefully you can see this. This is what's called a publicly accessible standard, and it was produced in partnership with various bodies, but it was led by the British Plastic Federation, and they are manufacturers and people who are involved in the plastic supply chain. And the standard was an attempt to support Operation Clean Sweep, or be the next development of Operation Clean Sweep, and really give them a standard to which they could, voluntary standard against which they could work to reduce the losses which were losses to the environment, which were coming through the stuff, through poor handling of plastics. Now, it's well worth, if you want a reference document, it's quite good because it does actually lay out things which people could do. And if you read this in conjunction with this webinar, I think you get a very balanced perspective on what can be done there. Now, let's just share back to my presentation. Okay, so a couple of other things I would say. Anybody got any questions? There were some questions in chat, but I think the most difficult one, I was trying to work it out in my head, and I'm not very good at that. What proportion of total plastics does riverborne plastic represent? Josh, your starter for 10.
Brilliant. Yeah, no, fantastic question. So just have a quick look. There is our report. So we've, as Kif has mentioned, we've had, again, a very superficial look into where the sources are coming from and all those sort of things. So that is on the website, and where you can put a link into the chat of where to find that. So on one of the papers that was shown there is basically saying that there's around 66% of microplastics entering the ocean comes from road runoff, with another 25% from waste, and then the other percentage coming from just direct input from sort of wind source. But I imagine, obviously, with that, it's quite hard to calculate, in the sense that what do we determine as a pristine river that doesn't have any road runoff input into it at the end of the day? There's some crazy statistics about the amount of tire wear coming off the roads, and then that just hitting into our freshwater environments. And similarly, again, with Kif, where the amount of microplastics within a agricultural field, we know full well about the effects of eutrophication. But if you combine that, we've got microplastics going into those drainage ditches that enter the stream. So yeah, it's definitely a fantastic question, and something I'm going to start looking up after this as well. That it's probably in reality the largest source, I'd argue, getting into there, but we can definitely have a little bit deeper dive into that.
Yeah, I think the Ocean Cleanup have some statistics on that. I mean, they regard rivers as being the principal pathway between the land and the ocean. That's, but certainly if you think of estuaries, if you catch it before it gets into the estuary, you've got a good chance of reducing plastic which is going into the ocean. But then there are the sources which go into that, which could be, fishing debris, which comes from operations at sea. But that's a possibility. Things I would also highlight is that there are a number of resources which you can delve into. I'm just going to stop sharing now, and I will share our website if I can get to that. What we have within UK and Ireland Spill Association. Can't do two things at once. Dot. Just going to get to. Right. Okay. If you, I'll share this now. Okay, if you go into our website, you're there into working groups, click down to plastic pollution working group. You can then understand what we're doing, our goals. And then if you click on the goals, for example, here, you'll then be able to see a presentation which explains the goal. And then this link will form in a minute. And in here, there'll be the link which is to the paper which supports that particular webinar. It will appear in a moment. It's just that my internet is pretty slow at home at the moment. So that is how you could get in. So go to each goal, you'll then get the supporting webinar, but you'll also get the link to the paper as well. So I hope that helps. So I'll unshare that. Go back to my presentation. Okay, so any more questions? Anybody got any more questions? Did I see one new message?
One there from Peter, which is fantastic. I don't mind answering that one, Mark.
Yeah, please. Yeah.
So yeah, with regards to do you have any links with any suppliers of agricultural plastics, and do they have any responsibility to recover used plastics? Unfortunately not, no. We've at the moment very much been sort of, it's been bubbling under the surface with us at the moment. We've been trying to get all this information out, and this is why we are doing these webinars, because we want to engage with everyone. We want to start building those relationships and getting those links in. Yeah, I think that's fantastic. There's a lot of, again, we deal with slurry spills anyway within our industry, and also from sort of large diesel spills. There's a lot more responsibility on agriculture and farmers these days. So I can imagine this is going to be coming sort of in the eye line more. So yeah, if you know anyone, that'd be fantastic. And obviously open invitation to anyone else as well. But yeah, you think about the amount of plastic that's used just within agriculture, it'd be brilliant. And also again, this is open invite really to anyone that from that list that we've gone through, if there's any other technologies that you know of and other methods from even just from the controlling at source, but also the recovery. So do have a look at those things and let us know. Put it in the chat, and we are more than happy to sort of have those conversations outside as well.
Yeah, the whole process with the plastic pollution working group, the philosophy of all the members is that whatever knowledge we gain, we share, and there's nothing which we're trying to hide or have direct commercial interest in, other than just basically trying to get information out there. Because it's only if we all do our little bit in whatever way we can to prevent the flow of plastics into the oceans, it will give the oceans the chance to try to recover from the harm that's being caused to them. But if we can stop it going in, then we have an opportunity to recycle that plastic, reuse it, and make it into something else, which would be great. Now, the next webinar in the series is getting on to the practical side of identifying effective equipment for microplastic recovery. And you can see one of our trials that we were doing with a sieve system there. And this will be presented, correct me if I'm wrong, Josh, by yourselves and Oil Spill Response Limited, possibly with the involvement of ITOF. Is that correct?
Yes, that's everyone that's on the goal too.
Yeah. Good.
Yeah, that's what's scheduled next. Start making the webinar. Yeah,
good. Now, this will be on the 15th of March at 1500 hours. If you have registered for this, you will get a series of invites to saying you can register and go through Eventbrite and all the rest of it. But as I say, we are happy to work with anybody, provided we can help share knowledge. And all that we're producing will be updated, and we're hoping, we will later on this year, produce a field practice guide, and that field practice guide will be aimed at people who have to plan for responding to these incidents, but also for those who do respond to these incidents. So it's really a practitioner's guide. Now, the group is also contributing to documents being produced by IMO, which is a sort of strategy, an overall guidance document. And then IPECA will be producing a more detailed strategy document. So looking at the strategic aspects of how we manage and prevent microplastic pollution. And our guide will really be aimed at the practical collection of it and planning should you have a plastic incident on your doorstep. So yeah, if we are here to help, and it's good to see that there's interest in what we're doing. So that's very much what this is this is being recorded. So within a couple of days, I will get the edit done and we'll get it up on our website together with the supporting paper next week. Anything to add, Josh?
No, apart from, yeah, thanks for all coming. I've just put my email address in the chat as well if anyone needs to get in touch. Otherwise, you can find me on LinkedIn and Kif and everyone through those avenues. So yeah, thanks again, guys.
Lovely. And I'd like to thank Josh and Kif for putting that together. It was very professionally done.
It was mainly Kif, so.
Well, I noticed that, Josh. Yeah, so you're obviously getting the.
I don't want to be left out.
You're going to do the majority of the next one then. Yeah.
Well, I don't know about that.
Okay, but gents, thank you very much indeed, and to all of you who've participated or joined in today, thanks very much, and have a good day.
Great, thank you, Mark.
Thank you.
Cheers, everyone.
Bye-bye.
Bye.
Thanks, everyone. Bye-bye.